This lesson is dedicated to revision of our knowledge about inheritance. The task is the following. We must create a class called figure, geometric shape, with the fields A and B, two sides of a shape. We will assign these values to the fields. This shape will contain one method area. It will calculate the area of the shape. Two classes are to be created. They will be derived from the class figure, and their name will be rect, rectangle, and triangle. Each of them will have two constructors. One constructor will accept one parameter, size, and set it to all the sides. Another one will accept the quantity of the parameters equal to the quantity of the sides, and set values to all the fields. For each one of them, override the method for calculating the area. The area of the rectangle is A multiplied by B. The area of the triangle is calculated by the Heron's formula. You can look it up on the internet. It's not complicated. Try to do it on your own. I will allow you several seconds to pause the playback of this video. Good luck! So let's proceed. Create a new project. Call it figure. And create a new class, figure. Here there will be only two fields of the double data type. Let them be called A and B. Declare a constructor in which we will assign values to the fields. Create method area, which will be public. It will return the area of the double data type. You may leave blank the body of this method, because we're going to override it anyway, in the class rect and triangle. But since it must return double data type, we must write the keyword return and some value. Let it be 0. At this point, it makes no difference after all. To calculate the area in the initial classes, we must have access to the sides. So let's create getters for them. We will do this using the keyboard shortcut. Press Alt plus Insert, select Getter, and both fields. Now let's create class rect. It's short for rectangle. It's derived from the class figure. And here is an error, because the class figure has a parameterized constructor, but not a constructor without parameters. So let's create a parameterized constructor for our rectangle. This constructor will accept two parameters, A and B. First of all, we will call the Superclass constructor and pass the received arguments. Our rectangle has two sides, so it does not require additional fields. Create one more constructor. It will accept one parameter, size, to set this value to all the sides. The superclass constructor must be created in any case. That is why we must call the superclass constructor before doing anything else. Write super, and as both parameters, we will pass size. Now we have set two sides of the same size. Let's override the method area. Press Ctrl plus O. Select the method we want to override, area. We will return A times B. Since we have no access to the fields, they are private. Call getter methods, get A times get B. That is all. We have finished working with this class. Let's create a triangle. The class triangle is derived from the class figure. Create a constructor. A triangle has three sides, so we will pass it three parameters, double A, double B, and double C. Call the superclass constructor. Pass it the values of A and B. The value of the variable C must be set for the third side. Let's create a field for it, a private field, private double C. Let's set its value in the constructor. This C, assign symbol, C. Now let's create one more constructor which accepts one parameter size. Call the Superclass constructor. Pass it size as both parameters. Set the value of size to our variable C. The last thing to do is to override the method area. Press Ctrl+O, select area. The area of the triangle is not so easy to calculate as the area of a rectangle. We will apply Heron's formula. First of all, we must find the half perimeter. To do it, all the sides must be summed up and then divided by 2. Create a double variable, call it P, assign symbol. We have no access to the field A and B, so we will call the getters getA plus getB plus variable C. Put this in the brackets. All this must be divided by 2. Now let's create another variable, call it S. It will be equal to P times, open the brackets, P minus getA times P minus getB and times P minus C. If it's unclear where the formula comes from, relax. This is not a math course. In this case, we use Heron's formula to calculate the area of a triangle if all its sides are given. You can find this formula on the internet. All we have to do now is return the square root of the result. Write return math.sqrt and the parameter will be s. That's it. Go to the method main. We still don't have it. Let's create it. Create the program entry point and new shapes. Let our rectangle be 5 by 10. And all the sides of the triangle will be 10. Let's print out the areas of the shapes on the console. Run the code. Well done! We haven't learned anything new. It's just been a revision of our previous lesson. Now give your attention to the class figure. Method area does nothing in it. It means that if we forget to override this method, it will return 0. This will not be what we want. If a method is not implemented and must be overridden, we should specify the keyword abstract and delete the implementation. Right after the round brackets, a semicolon is required. If a class has at least one abstract method, the class must be abstract too. Type public abstract class. The error is gone. I will explain soon what an abstract class is. So we have created the class figure, which contains common features of all shapes. Then we created specific classes, rect, rectangle, and triangle, which are derived from the class figure. We allowed users to create their own rectangles and triangles. Let's remove the word abstract and from the method too. Get the implementation back. Open the method main. Why not do this? Figure, assign symbol, new figure, 5 and 5. Print out its area. We got some abstract shape, the area of which equals 0. So if we want some class to be a superclass for some other classes, And at the same time, if we want to deny users from creating objects of this class, we can declare it abstract. And the methods bound to be overridden must be marked by this word. Let's get this back. We will make the method abstract, get rid of the implementation, insert the semicolon. Now if by some accident in some class, for example the rect, we derive something from figure, but forget to override the method, an error will occur. Hover the mouse over it. Class rect must either be declared abstract or implement abstract method area. If we want to implement superclass methods quickly, we can press Ctrl+I and select the method to be implemented. In this case, area. The error is gone, and here we will write our implementation. Return get A times get B. Once again, why the class is abstract? In reality, there are no abstract shapes. Any shape must have some name. A polygon, a tetragon, a triangle, a pentagon, and so on. Thus, to deny creating just a shape, we have specified the keyword abstract. If we want some method to be imperatively defined, we also mark it as abstract and remove the implementation. There are two more things to discuss before moving to our next topic. From the very beginning, I've been telling you that inheritance allows establishing the hierarchy of classes. It means that there is nothing to prevent us from deriving from a subclass. Let's say we want to create color rectangles. A color rectangle is both a shape and a rectangle, but it also has an additional parameter, color. We will do so. Create a new class, call it color rect, a color rectangle. It will be derived from the rect. Create a constructor in which we will call the superclass constructor. And also a constructor with one parameter. As you can see, there is no error, though we have not overridden the method area. It's because we derived this from the class rect, which already overrides this method. It means we already call a method implementation which is specified in the class rect. And the second thing, in any subclass, we can override all the methods of the superclass declared as public. It means we can override the method getA, which will return, for example, 10. If we do so, this will confuse people who will use our code. Unless we wish somebody to override our method, we can specify the keyword final. Do you remember that we have already used it for a variable, the value of which had to be left unchanged? In the methods, this keyword is used differently. It restricts overriding a method. Let's restrict overriding the methods getA and getB. Go back to the class rect. Here we can see an error. We cannot override this method. And the last thing, the keyword final used with classes restricts inheriting from them. If we write public final class and go to the class color rect, we will see an error. We cannot derive from the class rect because it's declared final. So the word final can be used in three situations. Firstly, when we declare a variable, the value of which we want to be unchanged, that is a constant variable. Secondly, if we don't want a method to be overridden in its subclasses, we specify the word final next to this method. And thirdly, we can specify final next to the classes to prevent inheriting from them. You have already had a homework assignment on this topic last time, so today you can relax. We have simply reviewed the material and found out what abstract and final are. Use abstract classes when it's needed. I mean when we have in fact described something abstract. For example, today we have created the class figure, shape. But in reality, there are no shapes as such. They can be either triangles or squares or circles. Yes, they all are shapes, but they all have their specific names, so it was logical to declare the class figure as abstract. Good luck! See you in our next class.